Hey, welcome back. So I have a confession. I am an absolutely terrible Python programmer. And this year I decided I was going to fix that. Now, the way I get better at different programming languages is to understand their essence. And that means understanding what influences, where the syntax came from, what is the core of the programming language. So I started to go down that journey with Python. And one of the things that I realized is that the core of Python comes all the way back to the dawn of Unix. So if I want to understand how to become a better Python programmer, I need to get really good at calculators. So before we go all the way back to the beginning of Unix time, we actually need to go a little bit more further forward in time and look at the original announcement that Guido Van Rossum, who is the creator of Python, made in Usenet. Now, that happened back in 1991 on February the 20th. Now, I'm not going to go through every line of the document line by line, but I am going to pull out some key bits in his tutorial to Python section. So here there's a little bit more information. Python is a simple yet powerful programming language that bridges the gap between C and shell programming, and thus is ideally suited for rapid prototyping. Its syntax is put together from constructs borrowed from a variety of other languages. Most prominent influences are from ABC, Modulo 3, and Icon. So it is fairly well known about the influences that ABC and Modulo 3 and Icon had on the Python language, and I will cover them in other videos, but actually I wanted to focus on this missing language that isn't on that list. And to do that, we need to actually follow Guido's own tutorial on Python within this very document, which is using Python as a calculator. So what we're going to do is we're going to start with Python, and then I'm going to show you the magic. So the first thing that Guido wants you to do in this tutorial is actually use Python as a calculator. And to do that, he has actually created a Python interpreter, which is version 0.9.1. Now, we're not going to use that version. We're going to use Python 3, but it will get across the main concepts, and then we will show you the magic language from there. So if I look at this document, you can see what he's saying there. The interpreter acts as a simple calculator. You can type in an expression at it, and it will write the value. Expression syntax is straightforward. The operators plus, minus, star, and divide work just as most other languages, e.g. Pascal or C. Parentheses can be used for grouping, and then he's got a couple of examples. This is a comment. He's going to do a 2 plus 2. He's going to do some grouping and division, and then he's going to do some division there as well. So we are going to do the exact same thing. So I'm going to open up the Python command line. So we'll just type in Python, and as you can see, I'm running Python 3. There's a couple of things I want you to see. You can see this dash 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 syntax, so sort of these angle brackets. So with the interpreter, I can type in comments. So I can do things like this is a comment, and then again, that was part of Guido's original tutorial. You know, there's a comment, single line comment, and it's just hash, and then whatever your comment is. And within the interpreter, I can do some calculations. So I can do 2 plus 2. And you can see that's going to come back with 4. And we can do the more complicated example that Guido had, which was 50 minus 5 plus 5 multiplied by 6 plus 25, and we'll divide that by 4. And then you can see it comes back with 25.0. So if we come back into Guido's original tutorial, you can see with that calculation, it's not a 25.0, it's just coming back with 25. And the reason that is because I'm running Python 3. Now, what happened in Python 3, there was a change where the original version and even up to Python 2 used a thing called integer division, right? And then after Python 3 onwards, that became float division. So what that essentially means is that you're going to get that point number whenever you do a division. So it's actually going to take float numbers into consideration. So if I want to get the exact same result as per the original tutorial, what I can do is just change that from, rather than being divide by 4, I can just go slash slash. So it's a double slash, and then I'm going to get the same answer, which is 25. And that's me forcing it to do integer division. And again, you can see the same sort of thing if I do another calculation. If I do something like 7 divided by 3, you can see it comes back with 2.3333. But again, if I come back to the original version, you're going to see 7 divided by 3 is going to come back with 2. If I want to get the same result, I would just do 7 slash slash, so double slash 3, and then it's going to come back with 2. If I want to exit out of this interpreter, then all I need to do is hit Control D, and then it's going to bring me out of it. So that is the Python interpreter. That is what you have today. Now, I promise you an old magic language, which will be able to do the exact same thing and had a massive influence on Python. And I'm going to show you that now. So we'll just clear my screen, and I'm going to type in BC. And that stands for Basic Calculator, or bench calculator, as it's sometimes known. Now, this was developed by Lorinda Cherry and Robert Morris of Bell Labs back in 1975. In fact, specifically, Lorinda Cherry did all the coding of this version. As you can see, already it starts to feel very, very familiar. Do you see those 3 angle brackets? Exactly the same as the Python interpreter. But we can go further than that. I can type in this is a comment. Single line comments, absolutely the same. I can do 2 plus 2, and it's going to come back with 4. I can do the 50 minus 5 plus 5 multiplied by 6 plus 25, and then divide that by 4, and I get 25. And it's already doing integer division by default, not float division. And then I can do the 7 divided by 3, 2. This is exactly the same output that you would have got from the original version of Python back in version 0.9.1 in 1991. The similarities are even greater, and I'm going to come on to that in a second, but actually I want to go even further back in time, because I said in 1975 Lorinda Cherry actually created this version, and what she did was created an infix version of another Unix utility which was called DC, which stands for desk calculator. And actually, Brian Kernighan reckons that it was the first ever Unix program. It's a reverse Polish calculator, so i.e. it's going to do things in a kind of stack type fashion, and it was written in a language called B, and B was the precursor for C. So we can bring that up. And by the way, if I want to exit out of BC, out of Basic Calculator, I can just do Control D. So to exit out of it, I exit out in the exact same way as I would my Python interpreter. So let's clear that. So before we go back to Basic Calculator, we're going to spend a little bit of time on Desk Calculator, just so you can get really familiar with how it works, and then you can understand the difference Basic Calculator made compared to Desk Calculator. So as I said, it's a reverse Polish calculator, so it essentially operates as a stack. So if I want to bring it up, I just type in DC, as in Desk Calculator, and guess, look, it's got the 3 angle brackets again, exact same as Basic Calculator, exact same as Python. And again, this is developed back in 1971. So as I said, it's reverse Polish. So if I want to do some calculations, I would just do 10, 20. So I'm going to add 10 to 20. I'll just do a plus. So what you're doing is you're essentially saying what the numbers you are. So think about the stack. I'm putting 10 on the stack, then I'm putting 20 on the stack, and then I'm going to have I'm going to do an operand, which is going to be plus. And what it's going to do is pop off the 10 and the 20. It's going to do the calculation, and then it's going to push on the result. So if I do that, I should now have 10 and 20 should be off the stack, and I should now have the answer 30 on the stack. Should be the only item. And if I put in P there, it's going to come back with the top item of the stack, which is 30. And again, I can do the same for other operations. I can do multiplication. So I can do 10, 20, multiply P, and you see it's going to come back with 200. I can do 10, 5 minus P, and it's going to do 10 minus 5, and that's going to give me a 5. And then I can do 10, 3, divide, and we'll put a P as well, and you see it comes back with 3. So it's doing the basic calculations there. And if I want to, exit it, I do Control D, just like I did, before. And I can actually do a little bit of scripting with that. So if I do echo 10, 20, star P, we're already getting used to this. That's going to be 10 multiplied by 20. And then output it, and that's essentially going to come back with a 300. And then I'm just going to pipe that into DC, which is Desk Calculator, and then it's going to echo out the result, and you can see it's come back with 200. And then if I want to, I can even do sort of file-based input. So what I could do is do vi calc1.text. So we'll just open up VI as an editor, and I'm sure a lot of people are going to shout at me because I said vi instead of VI. It's like, oh, come on, kill me. And then I'm just going to put 10, 20, star, and then if I want to, I can put a P there, We'll just escape that out. We'll save it. And then if I want to run that, I can just do dc calc1.text, and then it can execute it to 100. So that is desk calculator. As you can imagine, the idea of doing postfix calculations and dealing with the stack is probably a little too much for the average human being. So what you want to be able to do is use the standard mathematical notations that we use today, which is infix notation. And really that was the rewrite that Lorinda Cherry did. She just essentially created a new front end over the top of desk calculator, which became basic calculator or bench calculator. So if I wanted to, I can come back into bench calculator or Python, and we can see even further similarities. So before I do that, if I come back into Guido's paper, you can see it says, as in C, the equal sign equals is used to do and assign a value to a variable. The value of assignment is not written. So he's got an example here of width equals 20, height equals 5 multiplied by 9, and then width multiplied by height, and he's going to get the result 900. So if I want to, I can do that in Python. So we'll just type in Python, and then I can just do width equals 20, and I can do height equals 5 multiplied by 9, which is essentially 45, and then I can do width multiplied by height. So I've got variable assignment, so width is equal to 20. I've got variable assignment for height, height equals 5 multiplied by 9, which is going to be 45, and then I'm just going to do the calculating width dot height multiplied by height, and you see it comes back with 900. Again, if I bring up basic calculator, so if I just bring up that, I could do width equals 20, works the exact same way. Height equals 5 multiplied by 9, and then I can go width multiplied by height, and then it's going to come back with 900. It works the exact same way. So the exact example that you saw in Guido's own paper is the exact same in basic calculator. And this is where I'm going to move away slightly from Guido's paper, but I just want to show some more of the kind of similarities between basic calculator and Python. So if I wanted to, what I could do is do a num equals 0. Essentially what we're going to do is a little while loop, and then we'll do a while, and we'll say num is less than 50, and then we will do num plus equals 1, print num. I'm starting to think this is going to look familiar to everyone, and then you can see it's done 1 to 50. Now that's kind of C-like syntax as you would expect, except for the print. Print's not very C-like syntax. Now, if I wanted to in Python, remember this is close to Python, but remember that ABC type syntax and indentation. So if we look at how Python works, Guido wanted to get away from using C-style code blocks. He wanted to use the indentation style code blocks, which comes from the ABC programming language. I will do another video on ABC at some point, and you'll see that. And he will also get away from these parentheses as well, because again, that is very ABC style. So if we just come out of this, and what I'll do, I'll leave that terminal up there for a second, and then what I'm going to do is I'm going to open up Python, and then we can compare. And then what we'll do is we'll do a num equals 0, and then we'll do a while num is less than 50. So again, I've got rid of the parentheses. Yeah, they're gone. I'm not using them. So that's again taking the ABC syntax. I'm using the colon there, which again is really coming kind of from ABC type things there. Now I do the return. I'm going to put my tab in because I'm going to follow the indentation style. I'm just going to do num plus equals 1. I'm going to do the print. Now, if I look at the original version, if I did Python 2 or Python 091, it would have allowed me just to do a print num, but with the change to Python 3, they introduced brackets, and they really did that because they wanted the expression orientation for prints as opposed to being statement orientation. So, you know, I'm going to put the brackets, but if I went to the original version, it would have just been a statement. And then if I just run that there, it's going to do 1 to 50, and it kind of works in pretty much the same way. So if you look at it, the syntax there, the loops, the while loop is exactly the same as basic calculator. except it's using the more ABC style syntax. So next thing I'm going to do is we're going to come back to basic calculator for a second. And what we're going to do this time is we are going to create a function. So what I'm going to do is create a function that adds two numbers together. Very simple. It's the sort of thing we do all the time. So to do that, I'm going to create a new file. I'll call it add.gist because I'm sort of getting bored with typing in the REPL kind of format. So I'll just do something called add.text. And then I'm going to just put a comment here and we're going to say define add function. And then what I'll do to create a function in basic calculator, you use the term define. Again, I don't want to give away the game for when we look at Python, but anyone who's a Python programmer already knows that it's def, right? So see that influence. So we'll define, and then it's add, and then it's going to be AB. And then, of course, it's got, basic calculator's got the C-style syntax. So we'll add return A plus B, and we'll just close that off with the brackets. And then I'll just do print add 10, 20. We'll just save that. And then to run that, I can just do a BC minus Q add .text. And then you can see it comes back with 30. So it's added the two numbers together. So it's added 10 and 20. If I then come back into Python, let's exit out of this. We'll clear this. And what we'll do is create the exact same function, but this time in Python. Now, just so I've got the clarity there, I'll bring up the add.text in Python. So we've got it there and we can have a look at it in a second. So we'll create a new function called add.py. And again, define, I'm going to say define add function. So I'm using the same single line comment that we did earlier. This time, rather than using define, as you see there, I'm using def. And then I'm going to put add A, B. And then, of course, because it doesn't support C-style blocks, it's using the ABC programming languages style blocks. What we can then essentially do is go and create a code within that. So to do a return, I'm going to do a return A plus B. So there's another thing, right? It's the exact same here, right? I don't even need to do that. I can do this. So it's got a return statement, it's a define, and, I don't need to close off my blocks because it's similar. If I was doing original Python, I'm going to say what I said before, I could just do a print statement, but because I'm on Python 3, I can do add 10, 20. So it's almost identical. And if I was to run python add.py, you can see it comes back with the answer. So again, just to bring the two of them up side by side, single line comment, def, add AB, return, print, add. If I look at this, the only real difference between the two languages is the code block syntax and the indentation. That is literally it. So anybody who knows Python already knows that in addition to the while loop, that the for loop that is implemented actually comes from ABC, and it follows the for in syntax, so it's more of a kind of iterable. Whereas the for loop in basic calculator is actually just a standard C-style for loop. So there's a little bit of difference there. So this is why I'm saying it's sort of then mixing and matching. What Guido's done is pulling in the syntax of ABC in there. I'm not going to show you the for loop from ABC. We'll cover that in another video because I'm focused on basic calculator. But if I go a little bit further and look at conditionals and look at if statements, what you can see is there is another similarity. So what we're going to do is we're going to implement a Fibonacci function. But we're not going to do the recursive version. We're going to use a non-recursive while loop, and then that will also help us bring in the if statement. Now, to be very careful, because basic calculator doesn't support tuples, I'm just going to sort of expand that out a little bit. So it might not look exactly how you would normally do that if you were implementing this in Python. So what I'll do is I'll just create a new fib.python file. Rather than me sitting typing this out in VI, I'm just going to make my life a little bit easier. And what I'm going to do is I'm going to open it up in Visual Studio Code. And then I will just do def fib n. And then what we'll do is, yeah, that's pretty good code that it's offering me already. The else statement is going to be slightly different. So we will just do I equals 2. I'm going to do a fib1 underscore 1 equals 0. I'm going to do a fib2 equals 1. And then, well, I is less than n. And then I'll do fib equals fib underscore 1 plus fib2. I'll do fib1 is equal to fib2. Fib2 is equal to fib. And then I plus 1 there. And then we will return fib there. And then finally, what we'll do is print out the Fibonacci of fib. And I think we will do Fibonacci sequence 10 there. So that is our Python program. I'm not going to go into too much detail. There's a couple of things I want you to point out in the sequence of conditionals. Comparison is done by double equals, as you see there. The return is working as you saw before. We use a return statement. Python supports if, and then this elif, and then else. Again, it's using indentation. This bit is really not that important. All I'm really doing is, in order to do the Fibonacci, all I'm doing is sort of doing temporary variable assignment as opposed to tuples. And then what it's going to do is print out a Fibonacci of 10. So if I just save that, come back to my terminal, and I run python fib.py, you can see the Fibonacci, the 10th sequence of the Fibonacci is going to come back with 55. Now what I'm going to do is I'm going to implement the exact same code, but this time I'm going to do it with BC. So I'm going to bring back Visual Studio.code. What I'm going to do is I'm going to create a new file called fib.text. And then to be super lazy, I am going to copy the Python version into my fib.text. And then I'm just going to close that down there. So rather than, I could have my single comment, but I'm not going to do that. So rather than having a def, I would just do a define. And again, I'm going to use the C-style code blocks here. So we will just close this off like that. And then I'm going to do the same here. So C-style code blocks. C-style code blocks. And again, I need to put some parentheses around this. Put some C-style code blocks. So all I'm doing is I'm not changing the logic, any of the keywords, or I will change keywords in a second. I'm just BCing the syntax a little bit, and it's not massive changes, right? So the last one I'm going to do there is going to put an else there. We're just going to close that off here. And again, that while, it needs a C-style code block. This is a C-style code block. And then if we look at that, that's all pretty good. I need to just put some parentheses around here. Save that. And then the only other thing I need to do is that elif, that's a Python-y thing. What BC supports is else if. So if we just save that. And then the final thing all I need to do is, and of course, I wouldn't have needed to do this if I was running an earlier version of Python, is I remove the parenthesis just to make the print statement back to being a statement. So if I save that, and now if I run BC minus Q fib.text, if I'm lucky, it comes back with the answer 55. So as you can see, the way that if statements work, let's just bring that back up in Visual Studio Code for a second. The way that if statements work is, so this elif else, again, BC is using else if as opposed to elif, but it's close enough. The comparisons are the same. How it does conditionals is pretty much the same. There is not a lot of difference between the two. Now, of course, if I was doing this in a traditional Python way, I'd be using tuples, but of course, tuples aren't supported within BC, so that's fine. So if I come back to the original paper that Guido had written, of course, ABC and Modulo 3 and Icon have had a massive influence on Python. But if I'm truly honest, when I look at this, the impact that Basic Calculator and desktop calculator from 1971 and 1975 has had on Python as a language is absolutely huge. The interpreter that Guido written is identical to basic calculator and has even got the influence back to desktop calculator from 1971. The code structure, how it does conditionals, if else, the way it does calculations, assignment, the way the interpreter works, how you define functions, right? Rather than it's def rather than define, the impact of this else, if else ifs, etc. And of course they come from earlier languages such as Algol, etc. as well. But the impact that you can see that basic calculator had is absolutely massive. And even things like the print statement, and of course they come from basic, but again, you can see the impact that was part of basic calculator as well. So in short, if you want to become a better Python developer, then actually spend the time on basic calculator and desktop calculator. And I'm sure we'll probably do further deep dives in other videos or whatever at some point. But for me, I feel as if I have a little bit more essence of the language and understand it a little bit more. And hopefully it's been a little bit useful to you as well. So catch you in the next video.